If you want to truly understand AI, not just use ChatGPT, you need to understand the math behind it. Let's start with the foundation, the two most important pillars, linear algebra and probability. I'll explain them in the simplest way possible. The foundation. First, linear algebra. This is the backbone of AI. Computers don't understand words. They only understand numbers. So when you type king, AI does not store K-I-N-G. It converts that word into numbers like 0.82, minus 0.14, 0.55, 0.91, and thousands more. This list of numbers is called a vector. Each number represents a hidden feature of the word. Maybe one dimension captures royalty, another captures male, another captures power, another captures leadership. We don't manually define these. The model learns them automatically during training. Real-world analogy. Imagine describing a person using height, weight, age, salary, education. Each feature becomes a number. Together, these numbers form a structured identity. That's exactly how AI represents words. Every word becomes a numerical identity card. Why this is powerful? Here's something amazing. King minus man plus woman is approximately equal to queen. This works because vectors capture relationships mathematically. Words become points in space. Similar meanings are closer together. That's linear algebra in action. Language becomes geometry. Where matrix comes in. Now let's talk about matrices. A neural network is basically layers of matrix multiplications. Mathematically, input vector multiplied by weight matrix equals output vector. That's it. Every layer in a neural network is doing this repeatedly. Real-world analogy. Think of a weight matrix like a coffee filter machine. You put raw input in, it transforms it, and gives refined output. Like making coffee. Water plus coffee powder go through a filter and become coffee. In the same way, information goes in as a vector. Each layer filters and transforms it. That's how raw words become intelligent predictions. Slight technical clarity. If your word vector has 1,000 numbers and your neural layer has 1,000 neurons, the weight matrix contains 1,000 numbers multiplied by 1,000 weights. That's 1 million learned parameters in just one layer. Large language models have billions of these, all powered by linear algebra. Now let's move to probability and statistics. AI does not know the next word. It computes probabilities. If you type, "I love artificial," the model computes something like intelligence 78%, flowers 2%, rain 1%, music 4%. It assigns a probability to every possible word in its vocabulary, sometimes 50,000 words, sometimes even more. Then it selects one based on probability. What's actually happening? The model creates something called a probability distribution. Think of it like a giant list. Every word has a score between 0 and 1, and all scores together add up to 1. That's statistics in action. Real-world analogy. Imagine you're playing a sentence guessing game. If someone says, "Happy birthday," you already expect "to you." Why? Because your brain learned patterns from experience. It knows that phrase appears together frequently. Your brain has internal probabilities. LLMs do the same thing, but instead of intuition, they use probability theory trained on billions of sentences. Another simple example. If I say, "The sun rises in the," you predict east. Why? Because historically, that sequence has very high probability. AI works the same way. Prediction is pattern frequency converted into math. Why these two are the foundation. Linear algebra gives AI a way to represent meaning as numbers. Probability gives AI a way to choose the most likely next step. Without linear algebra, AI cannot understand inputs. Without probability, AI cannot generate outputs. Together, they create numerical understanding plus statistical prediction. That's the core engine of large language models. Closing line. AI is not magic. It's linear algebra turning language into geometry, numbers representing meaning, and probability turning patterns into predictions, statistics predicting the future. That's the foundation of modern AI. And when we add calculus and optimization, that's when machines start learning. Stay tuned for upcoming topics. Calculus, how AI learns; optimization, how AI improves; attention, how AI understands context.